So the key feature of the problems featured in this section are chain rule is going to be a part of the differentiation, but not the only part of it. So once again, we're featuring the chain rule, but they're not just all straight chain rule problems. Okay, so let's look at this. Here's your first one. Okay, jump in here and just try it. Okay, see how this works out, and then we'll work through it, but jump in and give it a shot. Okay, let me try. So let's set it up. Now again, I'm only looking for the differentiation rule, right? That's all I'm looking for. Here's my function. Now it would be possible just to multiply this out 4 times and then multiply by everything by x squared. That's a lot of algebraic work. It'd be x to the 10 and so forth. But I mean, if you're desperate, you could do it. I don't think it's the key idea. But okay, let's see how to look at it. I'm taking a derivative, and I'm just going to do it like usual, right? I mean, every problem in the last section was chain rule, so you just immediately went to chain rule. But now we're back to the regular thing. I want the derivative, so the function goes in, I apply the differential operator, the derivative comes out. Okay, I'm going to replace the function by its rule, right? And now I'm going to just look at it. Don't prejudice yourself and say, I have to do this first, I have to do this second. Do the most basic thing which comes to mind. Okay, so if you're looking at this, what's the first thing? Just what comes to mind first. The only rule that you can really use is the product rule, right? I mean, that's the only possibility. If you just go through your list, it's not the constant rule, it's not the sum, it's not the difference rule, it's the product rule. So just work yourself down the list. So product rule, okay? So now I took one problem and I broke it into 2 easier problems. Now this piece is going to be easy, 2x. But this one, okay, I'm not going to stress about. Let's just fold the page in half and work it out on the side. Right? So the 2x is the 2x. I don't have to make a big deal out of it. Just put it there. So now I want to concentrate on this piece. But again, don't stress out. We're going to work this out separately, and then we're just going to plug and chug. It's like modular. I'm going to find the answer over on the right. I'm just going to click it right back into this spot. Okay? So again, here's our problem. Let's just look at it. This is what I want without, again, having any, initial impression of how I'm going to handle it. So I want its derivative. I want to use, what's my function h? And I'm going to have to use chain rule, right? So let's just set it up as the usual chain rule problem. Here is my function, and I need its derivative. And again, here, go, practice. Pause the video and just do it. Standard chain rule application here. Okay, if I'm using the chain rule, I need functions f and g. So here's my rule, right? So g is going to be, well, the x material. And that means that my function y is going to look like that. Again, I mean, you don't necessarily have to write this down. You would, of course, have to have a function f and g if you're using the chain rule. Again, when sometimes you get forced to memorize all those formulas, and then you're making your decision anyway. But why not just say what it is? This is my function f, this is my function g. You can quickly just run this through in your head and see that you get the correct choice, right? And you're good to go. All right. Now, once I have my functions f and g, I need my derivatives, right? I need my derivatives. And again, I'm not saying you have to put in all the steps. When you have y to the 4, 4y cubed. When you have x squared minus 2, it's 2x, right? So I have my data just listed. And again, that's really all you would need so far, right? If you're writing all this down. I mean, for me, if you're writing all this down, you just have this line, and then you plug everything in and you're good to go, right? Plug in gx, plug in g, evaluate the function fy, right? Just fill in the box, clean it up, and you're done. All right? I mean, just do it on the side. Now, where did we leave off? Here's our original problem. Presumably, just again, fold the paper here, have the other problem worked out here, and then you just click it back into this slide. Just click it back, and now all the calculus is done, and all you have to do now is work through it and clean it up. On the exam, honestly, I'd leave it like that. But I mean, okay, some people get particular. Maybe they want you to clean it up. I'm factoring out this term, x squared minus 2 cubed. That's how I get this. But I mean, it's not bad to practice the algebra. You know, it's not bad to practice the algebra. You're not going to get better if you don't try it. Again, I don't like doing it either, but I mean, what can I tell you? Okay, that's our first one. Here's another one. Again, give it a shot. Just pause the video, try it, work it out, see how you do, and then we'll jump in on this. Okay, here's what we have. Right, here's our rule. And again, I'm not going to have preconditions. Let's just go about this. I like writing it as a power here. At any rate, you could leave the power in the bottom. I just prefer a power like this. I'll be up front. One way or another, you're going to use the chain rule. Whether you're going to use the chain rule with the quotient rule or the product rule, you're going to do the chain rule. So whether you leave the power in the top or the bottom, it doesn't matter. In fact, I very rarely use the quotient rule because one way or another, you're still going to have the power. But whatever you want to do. But I don't want the square root symbol. Okay. Now, if I determine the derivative, again, if you haven't done it, pause and do it. Right? Just start it in a standard way. Notice it's exactly as it was when we were doing them before the chain rule. Standard way. At this point, I'll make my decision. If you had kept it in more in this form, you'd use the quotient rule. If you do it in this form, you're going to use the product rule. And notice it opens up like this. And notice, whether you use the quotient rule as I wrote it down or the product rule, notice you get the same thing. You get a chunk of something times a derivative plus a chunk of something times a derivative. It's always divide and conquer, right? Break the one complicated problem into two easier problems, right? And I'll work those problems separately. Now, this piece here is pretty easy, so I'll just take care of it. This isn't, so I'll just break it off and work it on the side, right? This piece is easy. Be done with it. I mean, be done with it. The product and quotient rules wind up doing the same thing. They break the quantity into a chunk of something times a derivative plus a chunk of something times a derivative. And now I'll just put all my attention into this. This is its own problem. Just fold the paper in half and work it out on the side. So if you haven't done it, pause and give it a shot. All right, let me do it. Here it is. Again, it's on the side. It's its own problem. And I want its derivative. I mean, I have to use the chain rule. It's the only rule that'll work. So that's why I'm going to call it h. So that's my function h. And now it's a standard chain rule problem from the last lecture, right? If I'm using the chain rule, I need the functions f, g. I need their derivatives, fy, gx. And then I just plug it right into the chain rule formula. So if you haven't done it, pause and give it a shot. Okay, let me jump in. You have to find functions f and g. Here's my rule. I'm going to take g of x to be the x material. That tells me what y is, and then that specifies what the function f is. Again, there's no real choice here. So here's my function f, here's my function g. You can quickly check that it works. All right, I'm just skipping over this fairly quickly. If you want to pause and look at it carefully, that's fine. Well, it checks. So, okay, do it in your head. But I have my function f, g. Now I need their derivatives. Right, here's f. Here's g, right? Take their derivatives. Again, if you're comfortable just doing this in your head, that's fine. It doesn't have to be a project. I'm just going to emphasize again that there are the rules. And again, all the derivatives you're really doing are the simple rules. Here's my table of data. Here's my table of data. And I'm just going to plug it in. So g of x, gx is 2x. G is x squared plus 1. Fy, I just plug in again. Y is a placeholder. Okay, I plugged in. And now it's just a matter of simplifying. Okay, So now that I have this worked out, I'm just simply going to take this and plug it into the original problem. So here's my original problem. Again, fold the paper in half. You do all that work we just did on the right side. When you get the answer, just take it, plug it right back in here, and the calculus is done. I mean, again, you might want to clean this up, but for all intended purposes, that calculus is finished. So I'm just cleaning it up to work through the algebra. I'm going to get a common denominator, right? And then I'm going to combine these, and it comes out to be something clean like this. Why is this nice? Well, if you wanted to take the second derivative, right? Taking the second derivative of this would be a lot easier than taking the second derivative of this big mess up here, right? I mean, that's the reason why. So cleaning stuff up like this, second derivative wouldn't be too bad. Okay, so that's it. Now here's another one. Again, jump in and see how you do. Okay, again, give it a shot. Give it a shot. If you make mistakes, there's nothing wrong with that. That's why I'm working it out. But I want you really to try this. Okay, again, we're looking for the rule. Here's my function, but this isn't in the best format. X greater than or equal to 0 because it's square root. At the minimum, I want to get rid of the square root, right? X1/2. But also notice, it's just notation. When you write sine 2 like this is really what you mean. I mean, this is a better notation, but I guess it's not as compact. So, again, it's in your interest to write it like this. So notice I have x to the power plus minus constant sine here, but it's all to the power. So this is the correct form. So if you didn't have it, again, start here, pause and jump in. Okay, so determine it, the derivative, standard template, right? Standard template. Function goes in, apply the differential operator, derivative comes out, replace the function with its particular rule here. This is what I have. Now when we look at this, there's only one rule that can apply. Try it. I mean, there's only one rule that can possibly apply, the sum rule. That's it. No other rule will apply. Right? Remember, you have to know what these functions are. This is the first one. This is the second one. Okay? Now, I can work on the first term or the second term. If I work on the first one, I don't know. First term, you can just take care of that. I guess I took out the constant. It doesn't really matter. Okay, just doing the basic rules. Now, again, this one is pretty straightforward. Okay? And you don't have to make a big deal out of it. So all my effort really has to go into this term. And again, don't panic about it. Whatever it is, it's going to break down. It's going to be a chain rule, right? Because it's not just something squared. Okay, so just fold the paper in half, try working that out over here, and then we'll come back and compare. Okay, here's my, on the side of the page, right? I'm going to identify my function h, and I'm going to need chain rule. Right, here's my function h, I need its derivative. So if I'm using chain rule, I need the functions f and g. So let's go through that. I'm going to take g to be the dx stuff. Now again, this is one where you have a choice. If you took g of x to be 2x, it still works. One way or another, you know, you're going to have to do the problem. So, I mean, you're going to do the same things. I'm going to take g of x to be sine 2x, but you could have taken g of x to be 2x. It works. It's still the same. And that sets up y for me. So I choose f of y to be y squared, g of x to be sine 2x. Okay, you could have taken this to be square of sine y and g of x to be 2x. One way or another, you're doing the same things, right? And you can check your work. I just substitute in gx and then plug that into f and check that it worked out correctly. That's the key feature. You made your choices. So now once I have f and once I have g, I need their derivative. So try that. Okay, try that. Okay, so let's do it. Here's my f. I have y squared. So taking its derivative is straightforward sine 2x over here. So when I have y squared, I get 2y for its derivative, sine 2x. And you see, this is the issue here. Now, don't rush this. This is a chain rule itself, right? I mean, when you look at it, it's a chain rule. So break this problem off, right? And work this one out. So it's a chain rule in a chain rule. So what? In another problem. Break this out and just work this on the side of the page. This is its own problem. So again, I have to use the chain rule. This is my function. So just set it up as its own problem. Again, on the right side of the page, you have all these problems working. It doesn't matter. You finish the one, you go and put it in the next one. They're just embedded, right? One class calls another class calls another class. So what? If I'm using the chain rule, right, I have to find the functions f and g. In this case, I have g of x equals 2x, right? So that tells me what f of y is. Right, so I have f equals sine, and g of x equals 2x. And again, you can check. I know it just gets tiring, but I mean, it's not a bad idea. It checks. Okay, so now I have f and g. I need their derivatives. Here's f, here's g. Notice at the end of the day, taking their derivatives is pretty straightforward. Right? It should always be. You're always breaking down the problem till you get it down to the basic components. So here's my data. Right? Here's my data. I just plug it directly into the chain rule. Right? Gx, g, evaluate fy. Right? Plug in. There you go. Clean it up. Okay, so now I'll just take this, it's modular, just take this and click it back into where we left off. Here's where we left off. This was the first detour, right? This was the problem we were working on, right? This is where we left off, right? This was the first detour, right? So I'm just going to take what we just obtained and click that right back in here, right? Just click it right back in there. And then here's your data, and I'm just going to work all this out. I plug in gx, I plug in g, right? I come down here and evaluate the function by plugging in, right? And now I just have to clean up. So that's what this looks like. Now I'll go back, see this was my first detour. I'll go back to my original problem and just plug and chug this right into the original problem. Here's my original problem, if you remember. And here's where we left off. Now I have that, which I just obtained. Hopefully, again, like you're working all this out on the right. So your first detour would have been up at the top. Your second detour would be in the bottom. So I solve the second one. I plug it into the first one. That gives me the first one, and I plug that back in here. And you're done. It's just about cleaning it up. And this is a hard problem. I mean, this is generally a hard problem. And people have a lot of trouble with problems like this because they try to do it all in one line. They try to do everything in their head, a chain rule and a chain rule in their head. I personally think that's exactly the wrong approach. Do it like I'm saying. You should just keep breaking it down, and you should never have to work too hard. I mean, you may solve it in a few lines less than me, but I'm guessing with this approach, you'll be right more often. Okay, this is just about cleaning it up, and then we're good to go. So again, that is not an easy problem, but I hope if you broke it down that way, it went fairly well. Okay, here's another one. So jump in and try it. Notice the new feature here is I want the second derivative. How do I get the second derivative? You obtain the first derivative, and then after you have the first derivative, you take the derivative of the first derivative, and you get the second derivative. So jump in, pause the video, give it a shot. Okay, let me try. The key feature, again, I have the power, so it already has the power. There's nothing really to do here. Take the derivative in the standard manner. Again, what I want you to see, it's always a template. What's the thing to do here? Well, I have the 2, take out the 2. Now I'm stuck with this piece. All right, I'm going to have to use the chain rule. No basic rule applies. Fold your paper, work it out on the side, and then we're just going to plug it right back in. Right? Just plug it right back in. Think of it as modular. You just plug the component into it. Here's my problem. Okay, so that lets me identify my function h. It's chain rule. I want to find its derivative. So I set it up as a standard chain rule problem like in the last lecture. If I'm using chain rule, I need f and g. Right? Again, if you haven't done it, please try this. Okay, here's my g. And that automatically gives me my function f. Right? So I have my functions f and g, and I check. Right? Again, quickly, I'm just going to go through this. You can check. Right? It works. And now, once I have f and g, I need their derivatives. Right? I need their derivatives. There's the derivative of f, derivative of g. And again, I mean, I don't know if you put the steps in. They'll only start to look the same, right? Y cubed 3y squared, x squared minus 1, 2x. Here's my data. Again, that's all I think you really need, the data and then this line, and work and finish it out. I plug in gx, I plug in g, I evaluate fy, right? In the standard format. And now I'm just going to clean up the algebra. So this is done. I'm just going to take it. This is where we left off. And I'll just plug it right in there. And clean up the algebra. And you've got the first derivative. Right? Now to get the second derivative, I just take the derivative of the first derivative. So again, give it a shot. If you haven't done it already, pause and jump in. Okay, so here's the problem restarting again. Here's really my step 0. And then here's my first derivative. Now just find the second derivative. The derivative is the derivative. The second derivative is the derivative of the first derivative, right? So the first derivative goes in. We apply the differentiation operator to it, and we get the second derivative out. I replace the rule, just put in the specific rule. Now, if you look at this, what is the steps you're going to use? Well, the only thing you can do is to first take out the constant. I mean, that's the only, well, I guess you could do a product rule. Anyway, take out the constant. Now you look at this. What can you do? Product rule, right? It's product rule here. And again, it makes sense to take the constant out in the first step. Why carry the constant around with the x's? I mean, it just saves effort. Now, if you look at this term is easy. So let's just clean it up, right? Just knock it out. And then we're stuck here. And this, they're only, well, you could really, actually, you could just multiply it out, right? I mean, you could just multiply this. That's only squared. That would actually be easier. But let's try it with the chain rule since we're practicing with chain rule, right? You see, you could just multiply this out. It's just squared, right? It'd be s to the 4th minus, what, 2x squared plus 1? I mean, it'd just be a polynomial. But anyhow, try the chain rule since that's what we're practicing. So I'm going to fold the page in half. Okay, let me go. I identify the function h since I'm talking chain rule. Think of it as a chain rule problem. I need f and g, right? So again, I'm going to take g to be the x material. And then that automatically sets up what I choose for my function f. So I have my choice of f and g, right? And check quickly to see if everything works out. And it does. I made the correct choice. All right, plug into the chain rule, right? I'm going to need their derivatives. So I have f and g, I need their derivatives now. So here's f, here's g, and I'm going to need their derivatives. Again, I put in all the steps. It always seems to be the same ones. And it is. Why look in the homework? I mean, it's amazing how all these kind of things pop up. Here's my table of data, which is really, I think, all you need on the side. This, and then just plug in. I plug in gx. I plug in g, I evaluate fy, right? Plug into the box, and clean it up. There it is. So I'm just going to go back to my original problem and plug it in. So hopefully you have this all worked out on the right side of the page. When you get the answer, you just come here and you plug it in, right? This is on the right side over here. You just plug it in. Calculus is done. Just clean it up. Right, just clean it up. I think I factored out an x squared minus 1, but you just multiply it out, clean it up, it comes out to this. And then you can, I don't know, you can put the 12, who cares, right? And that's it. So again, it's an involved problem. The problems in this section weren't just straight application of chain rule. But again, constantly think about breaking the problem down. If you're ever doing more than a basic derivative, you should break it down more, right? I think that's the key to solving these things efficiently. So try a few problems, we'll work them out in the lab, try some, and you should be comfortable with it. If not, you should talk to us. Okay, now here's another one. This is, again, it's a second derivative. So it's more involved. Like I said, we're just practicing. Give it a shot. So pause the video, jump in, and then I'll do it in a moment. Okay, here's your function. Right, nothing fancy, nothing to do, sines, cosines. I'm going to do the first derivative, set it up in the standard way, and you see I'm stuck with the chain rule right now. I'm stuck with the chain rule. There's nothing else I can do right away. So again, I mean, you don't really have to break this down. I'm just trying to push this idea, right? I'm just trying to push this idea. It already is set up, So there's my H. I have to find F and G, right? F and G. So I'm going to take G to be, it doesn't make much sense to take, you'll see if you try it. You can't really take G of X equals X. You're not helping the problem. I mean, you can try and see, but you don't really solve anything. So G of X is going to be the cosine of X, and that sets up my Y, and so my function F of Y is sine Y. So I have my F, my G. I'm checking again. I know you get tired, but again, I'm going to not do it wrong for that reason, right? So it checks. I have my functions f, g. I need their derivatives, right? I need their derivatives. Here's my function sine. Here's my function cosine. I just take their derivatives. Okay, so here's my data. And I just apply it to the chain. Like I said, I think on the side, all you really do is this and this start here, right? Plug in gx, plug in g, right? Evaluate fy of g, right? So I'm plugging in cosine into the box. Cosine, now again, what does this mean? I don't know. It's just a calculus practice problem. I'm going to take the sine out. So minus sine out, minus sine cosine. But, I mean, I don't know. What does this mean? Now I'm going to plug this in, right? My bird, I don't know if you can hear, he's having a fight. I played a YouTube video, so he fights with it all day. So he's happy, screaming. Anyhow, sine of cosine, right? And we did this derivative right on the side. Okay? Now that's the first derivative. Now, again, when you want the second derivative, that's the derivative of this, and that's not easy. But you just have to break things down. This is our starting point, right? This is the step 0 for the second derivative, right? This is my starting point. That's my function. And if I want, okay, I'm going to, I like to take out the constants, right? Minus 1 is a constant, is what I'm saying there. Now, if I want the second derivative, it's the derivative of the first derivative. Now, again, I'll let you go here, pause, give it a shot. Now, this is obviously going to be more involved. Okay. First thing I'm going to do is take out the constant, right? Oh, it's the easiest thing. Now I look at this, and I'm thinking product rule. Product rule. Now I break it down into two. I mean, it's an intimidating problem. But the sine is no big deal. Cosine, and I'll worry about this later, right? Sine is no big deal. Cosine. So look, I broke this down, and now I just have to worry about this. This is going to be the chain rule. If it's a chain rule, I need f and g, and I'll just go from there, right? That's all it is. Don't sweat it. Just break the page down. This is all done. This is my problem. Right? That's my problem. So if you haven't done it, pause and try it. Here I have it. So that tells me my function h is cosine of x. Okay? It's its own chain rule problem. If I'm using chain rule, I have to have f and g. And again, practice this if you haven't. Again, by working these out with me, you should be in good shape. I need f and g. Here's the setup. I'm going to take g of x to be the inside the cosine, the x material. That tells me what y is, and that tells me what f of y is, cosine. It's just a coincidence. They're both cosine. But again, notice different variables. They're different functions. These are different variables. Okay? Check. It all works. It all works. Check. Okay, now I have my functions. I'm going to need their derivatives. And here it all is. Here's my function f. Here's my function g. I need their derivatives. Again, the variables are different. So what? I mean, it doesn't matter. Sine, cosine, whatever. We're just going to plug and chug. Here's my data, and I'm just going to plug it right into here. So I plug in gx. I plug in my g. I evaluate fy here. Right? Plug into the box. Right? Automatic, 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 and there it is. Clean it up. Again, I don't know what it means. Sine of a cosine, whatever. That's what it is. Now I'm going to take this and I'm going to plug it right back in. So hopefully, again, like I said, the page is folded. You've worked all this out here. It's modular. I'm just going to take that expression, which I have on the side, and I'm just going to plug it directly in, and you're done. I mean, I don't know. I mean, what does it equal? It equals, I don't know. Cleaning it up. Sine together is sine squared. And that's what I have. I mean, I don't know. It's just, it's a test problem. It's a homework problem to see if you have your act together. It's tough. But what I'm trying to emphasize is if you're organized, you can work your way through it without excessive pain. Now, I'm not saying it's not long, but if you're organized and taking the tips I'm giving you, hopefully you have no problem. Okay, well, that's the last one we're going to work out today. So, again, we're going to work on one in the lab, practice some of the homework, and you should be good with it. If not, talk to us. So, okay, good luck with them.